Today we are going to be looking at the second aspect of chain rule that we have here, which is if you have y to be equal to the square root of a function of x, how do you differentiate that problem? Now, what you are going to do for me now is to subscribe to this channel. Clicking that subscription button is free. Subscription is free. Please click the subscription button. Ensure you have subscribed. It's very important. Then the next thing you're going to do is to please help us to share this video to others, share this channel to others, because we are going to be gaining a lot from this channel. I'm Tutor Gustaf, I'm the engineer Stanley by name, and we'll be looking at both mathematics and physics in details. As far as this channel is concerned, you can put your comments and your requests in our comment section so we can review it, know what we have to update about the channel. So let's go to this. Let's go to this. And please don't skip any part of this video. Don't skip any part so that you can get the full explanation, full knowledge about what we are about to dash out now. So God bless you. So let's look at this. Now, the first question we have here is, I'm going to be doing it using two methods before I use the first method. Now the first question is, both of them they are teaching you anyway. Teaching you. This is just like the first one we did, but in another dimension. So if y is equal to the square root of x plus 1, what is the over the x? Now the first thing I'm going to do is to remove the square root and put equivalent sign that will take care of the square root. What is equivalent to square root? What is the same as the square root of a number? That's what I mean. What is the same as the square root of a number? Now the square root of a number, means that number raised to power half. Like the square root of a number. That number raised to power half. The cube root means that number raised to power 1 over 3. And so on. So the next thing, let u be equal to x plus 1. Such that if I differentiate this u, I'll be having differentiating x, I have 1. Differentiate 1, you have 0. So that is 1. And the question itself will be equal to u raised to power 1 over 2. That's what we have. That's what we're going to be having. We're going to be having u raised to power 1 over 2. And let's differentiate this du. The y over du will be equal to, then remember it's half times u, then half minus 1. Okay, the remaining differentiation. That will be equal to half u. Half minus 1 will be minus half. And this one will be equal to half times. Remember, anything raised by a negative number, any number raised by negative power means 1 over that number. If you want to remove the negative power, and we also said anything raised by half means the square root of that number. So you can also say half times 1 over the square root of u, so that we'll be having 1 times 1. That's 1. 2 times root u, that's 2 root u. That's why we'll be having to differentiate u raised to power half. That's what we'll be having. Then the y over the x will be equal to dy over du times du over dx. dy over du times du over dx. So that we'll be having, what's the y over du? 1 over 2 root u times, what's the u over dx? Just 1. So we'll be having 1 times 1, that's 1 over 2 root u. Then remember u is the same thing as what? U means 1 plus, that's s plus 1. S plus 1. That will be the answer. 1 over 2 root x plus 1. That's what we do. First thing, put equivalent stuff that will represent that root, square root, which means the number is per half. Anything is per half means the square root of that number. That's what it means. Next, replace the inside. Using that first approach we did, replacing inside with u. The ratio you have 1. Then the question will now be u raised per half. That will be the question. Rejecting the question is you're going to have half times u, then half minus 1. Half minus 1, that is minus half. The next thing, removing this minus by taking the reciprocal of that u, which is 1 over that u. I want to remove this one from indices, roots of indices. Indices, from roots of indices, a raised to power minus 1 means 1 over 8. That's from the roots of indices. So in the rest, you will just take what is u raised to power half. A raised power half of indices means the square root of A. It only means the square root of A. That's how it is. Or A raised power 1 over n means nth root of A. You can also say A raised power 1 over m. A raised power 1 over n. N means the nth root. The nth root of A means the nth root of A. If it's 2, the square root is 3 will be cube root and so on. That's how indices work. Yeah? That's why I said, okay, U raised power half means the square root of U. We already said that the square root of a number means that number raised power half safe. So there's no problem or there's no big deal about that. So next, 1 times 1, we have 1. 2 times root U, that is 2 root U from source. The next, from chain rule, divided by the s will be divided by the u times 0 by the s. What is divided by the u? 1 over 2 root u times 0 by the s is 1. So 1 times this, things is medicine. What is u? X plus 1. That is u. And there's another approach different from this first one I just did, which is if y is equals to the square root of a function of x, dy over ds must be the f prime of that function of x divided by 2 times the function, the square root of the function of x. Now, look at what I'm trying to say. This will be the answer to the problem. Look at what I'm trying to say. What I'm trying to say in a very simple language is, if you have y to be equal to the square root of a function of x, dy over ds will be the differentiation of what is inside the root divided by 2 times the former question, 2 times the initial question. That's what we are trying to say here. Look at what I'm trying to say. Look at it. From this question, I want to apply this formula to this question now. So I see it. Our function of x is 6x minus 3. Then, if you differentiate this function of x, you're going to be having 26x, you have 6, 23, you have 0, you will have 6. So the answer to this question now will be dy over ds is equals to differentiating inside this bracket, you will have 6 over 2 times the question. That will be the answer. You can do it this way to check out and discover that this is the answer you're going to get. And 2 here, 1, 2 here, 3. That will be 3 over root 6x minus 3. That's what we have. Let's say 2a, question 2a. Let me see, I want you to do this now. If y is equals to, let's say, the square root of, let's do this with exponential 2x. The square root of exponential 2x. And you know that y over ds will be equal to exponential 2x all over the root of exponential 2x. You can also do salt. You can also use salt to run everything. So that the final answer will be exponential 2x root exponential 2x all over exponential 2x. So everything will just be exponential, the square root of exponential 2x. You use salt to rectify everything. Before you know it, you get the square root of exponential 2x. For example, now, you multiply this one with the square root of exponential 2x, multiply this one with the square root of exponential 2x. So the final answer will be equal to root exponential 2x. That's what we have as the final answer. That's what we have as the final answer. That's what we have. That's what we have. So the next question. The next question will be, let's say we have, if y is equals to the square root of 8x plus 5x minus 1, dy over dx will be equal to, differentiating inside the bracket, differentiating 8x squared is 16x plus differentiating this, we are going to have 5, differentiating this is 0 over 2 times the question, which is 8s squared plus 5x minus 1. The same thing with this, the 1 over the s will be, differentiating cos s, you have minus sin x over 2 times root of cos x. That's what you're going to have as your final answer. So please try your best to ensure you grab this solution. It's a very simple thing. And in case you are confused about this, let me just show you how to run through that. The question was exponential 2x over root exponential 2x. That's our final answer. Because if you differentiate exponential 2x, you're going to have 2 exponential 2x over 2 times 2 cancel 2. Everything will be this. Then from solve, use the conjugate of both sides to multiply each other. So if I multiply something with minus exponential 2x minus exponential 2x, the thing will still be this one times root exponential 2x, this other one times root exponential 2x. This will multiply this will multiply this. So we'll be having this times this, we will have exponential 2x root exponential 2x. This times this, the root will cancel out, we'll have exponential 2x. This will cancel this, we'll be having the square root of exponential 2x, which is the same thing as the initial question. So please ensure you subscribe to this channel. See what we are doing here is not a child's play. We are solving real mathematics here. So please ensure you subscribe to this channel and share the video. God bless you all.